All right. Surface area of pyramids and cones. Unlike prisms and cylinders, which have two bases, pyramids and cones have only how many bases? Person? One. That's right. So already I have to use a different formula because my 2b formula is not going to be 2b anymore, just 1b. So instead of having two bases on a rectangular prism, a rectangular pyramid only has one base. The other base has been replaced by what you call a vertex. A vertex has no area. It's just a point. So I am not going to be finding the area of two bases today. Something else has changed too. In a prism or even a cylinder, all the lateral sides, now the base is a circle or a rectangle or a triangle, but all the lateral sides were always rectangles. All the blue sides are rectangles, even that one, when we unroll it, right? It's a rectangle. What are all the lateral sides in this pyramid? Xander? Triangles. That's another change we're going to have to make because the triangle formula is a little bit different from the rectangle formula. What about the lateral side in this cone? Yeah, we'll get to that. We'll get to that. Okay. Let's start with the rectangular pyramid. Like we did on Friday, I'm going to start with asking you how many sides there are. So Christian, how many sides are there on a rectangle? How many? There are 5. There's the base, and then there's every side of that rectangle base has a triangle coming off of it. So 4 lateral sides and 1 base side makes 5 total sides. Let's start with that base. If they don't give me the length and the width, I'm going to have to make the assumption that it's a square. So Jacoby, what would the area of that square be? 64. Awesome. Why send 1? Send 8, right? Yeah. You too. All right. So 64 is going to be our base area. Now, again, I'm not using any special formula. I'm just trying to use common sense right now. Plus, I have lateral triangles. Now, the height of each of these lateral triangles is going to be 14. So they all have the same height. Additionally, they all have the same base because this is a square base. So it's 8 inches on that side and 8 inches on this side. And so what that means is on this square, I know it says rectangle, but same thing. Well, not quite. A square is a rectangle, but not the other way around. On this rectangular pyramid, because I have a square base, all 4 of my triangles are going to have the same area. So I can put a 4 and then parentheses. And then who remembers what the area formula is for a triangle? Carter?
Base times height divided by 2.
Okay. That's right. So my base is 8. My height is 14. All right, so I need to go ahead and solve for that. I already know the base area is 64. Yeah, go ahead, Lizzie.
Could we use the 4, a 2, and depth of the 1/2?
We could. We could go ahead and cancel that out right now. And then I'm just doing 2 times 8 times 14. Maddox, what is 2 times 8 times 14? Calculators. Maddox is doing a double take, trying to figure out what side he put his binder on. His desk. Maddox, 2 times 8 times 14. 225. 24. Okay. Thank you for correcting me. I'm going to put this 2 up here. Okay. Maddox, since you already have that number still in your calculator, probably easy for you to go ahead and just add 64 to it and tell us what our total surface area is going to be. 288. And what's my label? Okay. Are we labeling on our work papers? Good, we should be. It's really hard to not label anything on your homework paper and then all of a sudden on quiz or test day, all of a sudden remember how to label everything or remember to label everything. Okay, bad habits are hard to get out of. Okay, like a soft bed, easy to get into, hard to get out of. We want to make sure we avoid those bad habits. Okay, so label our answers. Every area question is always square units. Now that wasn't so bad because all four of these triangles were the same size. If this were another type of rectangular prism with an actual rectangle base, something that looks like that, I would want to make, that doesn't look really good. That looks like a triangular prism. I did not do a good job of connecting them to a point. I'd grade that as an 8 out of 10. All my triangles would be different because I have a different length than what I have for my width. And so what I would do is I would need to do 2 triangles instead of 4 that are one size, and then 2 more triangles that are another size, and adds just a little extra work because I have to do the triangle formula again. Okay. Let's talk about a triangular pyramid. Now this is the oddest shape of them all, I think. Every side's a triangle. The base is a triangle. And because the word pyramid is being used, you know, all the lateral sides are also triangles. So every side's a triangle, and they're not all the same either. How many sides do I have, Brady Schnurple, on this shape? 4. Yep, 1 base triangle and 3 lateral triangles. I lost one of the lateral triangles because I lost a side on my base. Now I have 3 sides instead of a 4-sided rectangular pyramid. Let's start with the base first. To find the area of that base, I'm going to use the triangle formula. Someone already said it's 1/2 times base times height, and my base is 8 and my height is 6.9. So since they're using decimals, maybe I use a decimal. Maybe I use 0.5 for 8, or maybe, or not for 8, but 0.5 times 8. Maybe I just do 1/2 of 8 in my head. What's half of 8? Lucy? Or you guys can interact. Feel free to shout out answers. I really don't care. I know that may not be the case in other classes, but I'm okay with that. So 4, and then I just do 4 times 6.9. That's going to give us 27.6. That's the area of that base triangle. Now, I'm going to add that with my other lateral triangles. My lateral triangles are all going to have the same height. Again, it's 14. And because they didn't tell me what this side and what that side are, I'm going to assume that the only reason they didn't give me those 2 sides is because this is an equilateral triangle. It may not look like those 2 sides are the same length, but again, it's all about perspective. So that means this is 8. That means that's 8. It's an equilateral triangle. What does that actually mean? It means that I'm going to have 3 triangles that are the same size. Instead of 4, I've got 3 this time. They all have a base of 8. Not 6.9 this time. I'm looking at these triangles. Base is 8 still, but the height is now 14. So 1/2 times 8 times 14. Now, this time I would do 1/2 of 8 in my head, but I don't know what 4 times 14 is. So instead, let's do 1/2 of 14. Martin, what's 1/2 of 14? 7, and what's 7 times 8? So now we know everything in parentheses is 56. Martin, just tell me what 56 times 3 is. 168. Again, I'm all about saving us some time. So if I don't have to type as much in my calculator, it saves me time. I'm going to add 168 with 27.6. I'm going to get a total surface area of 195.6. And Oliver, how would I label this? Inches squared. So there's 2 examples of how to use the pyramid formula. Well, not even a formula, just common sense. So like I said, if you're not a big fan of using the special formula, you can still use common sense to get it done. If you are a fan, how many of you guys have been using the 2b plus pH formula? About 3/4? Okay. If you are a fan of using the formula, I'm going to give you another one today. And just like the prisms and cylinders where it was 2b plus pH and 2b plus CH, they're very similar. These 2 formulas are also going to be very similar today. Here is our surface area of a pyramid formula. And again, the nice thing about it, it works for any pyramid. Triangular, yep. Rectangular, yep. Square, yep. Octagonal pyramid. Don't know how to find the area of an octagon, but if I did, yep. Works for all those. Capital B plus 1/2 PL. That's a lowercase cursive L. You'll see that written a lot. It's not cursive. I don't really write my letters in cursive, but you'll see it in the textbook as a cursive L, or you might see it in the Big Ideas homework as a cursive lowercase l. Okay. The capital B stands for the same thing it did previously. It stands for the area of the base. Now you'll notice there's not 2 in front of it because, as we mentioned, pyramids only have 1 base, so 1B. The 1/2 PL. Why did that change? Well, it changed because our lateral sides, instead of being rectangles, are all what shape? Triangles. And because it's a triangle, of course there's going to be a 1/2 in that formula, right? To find the length, or to find the area of that triangle, I have to do 1/2. The perimeter part's actually the same. That part still carries over. The perimeter of your base, okay? Find the perimeter of your base. That'll give you all the bases of all 3 of your laterals, or 4 or 5 of your lateral triangles all added together. The L is no longer an H. That's because, just to take you back one problem, I never actually used the height of that prism. The height of the prism would look like this. It'd come right down the middle and it'd meet right there in the middle. That is not something I need for surface area. I do not need you to tell me how tall the prism is or how tall the pyramid is for me to find the surface area of it. I need you to tell me how tall the triangle is. And so this L that we have in our formula stands for lateral height, the height of your lateral triangle, also called slant height, because it's slanted, right? It kind of looks like it's angled over, slanted a little bit. So lateral height or slant height. I don't actually need to know the height until I'm doing volume, which will be next week. Okay, so it's not H, it's L for that reason. So the triangle formula is 1/2 base times height, 1/2 perimeter of my base times slant height. It's the same formula. I'm just using different numbers to plug in. Okay, so if it really does work, and I might still have some skeptics out there, so just in case, if it really does work, then I should be able to get the same answer for both of these. So I'm copying that work down just to show you that it's going to be the same. So my formula says surface area equals B plus 1/2 P, capital P, L. The area of my base is 8 times 8. Well, that part of the formula is definitely the same. Plus parentheses. I'm just going to use parentheses because there'll be a lot in here. 1/2 times the perimeter of that base. It's a square. So if each side of the square is 8, what's that make the perimeter of that person? 32. Excellent. Running out of room. I'll scoot you over a little bit. And then the slant height is 14, or the L stands for lateral height. I'll say slant height a lot. That's what I'm used to saying, but it's the same thing. So since this is 64, I know that this will work as long as when we do 1/2 of 32 and times it by 14, I better get 224. If I don't get 224, I'm not going to get the same answer. So 1/2 of 32 is 16, and 16 times 14, oh, man, just kidding. It's 224. I got you good, didn't I, Jimmy? Yeah. He's like, what just happened? Yeah. Yeah, so I'm going to get the same answer, 288 inches squared. So that works. You're still skeptical? I'm glad you said that because I have another one. Now I'm going to copy and paste the work for this triangular prism. Put it here. Shrink, 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 shrink. I can barely read it. It says it's 195.6. So I better get 195.6. Let's see. Surface area equals capital B plus 1/2 PL. Good idea to go ahead and write these formulas on top of our work paper so we can always go back to them. And like I said, if you want to memorize it, help yourself memorize it, write it at the top of every problem that you do. And just plug in underneath it. Capital B is going to be 1/2 times the, because it's a triangle, so triangle formula, 1/2 times the base of 8 times the slant height of 6 point, not the slant height, sorry, times the height of the base, which is 6.9. And we said last time that that was 227.6, if I can read my tiny writing there. So that's going to give me 27.6. That part of it was the same. Haven't done anything different there. Plus, scoot you over a little bit, 1/2 times the perimeter. Now it's an equilateral triangle. So Emerson, if it's an equilateral triangle and one side of it's 8, all of them are going to be 8. So what's the perimeter? 8, 8, and 8 makes 24. That's right. So 24 is my perimeter. The L is my slant height of 14. And last time we did that, we got 168. Let's see if we get 168. Half of 24. What's half of 24? 12. 12 times 14 is 168. Awesome. That's going to give us a grand total of 195.6 because that's what we got last time. I'm not smart enough to have that memorized. I'm just looking down at my last answer. That's how you use the formula. So feel free to use the formula on all of your pyramid formulas or pyramid problems tonight. I'd like to direct our attention to the next shape, a cone. Oh, cones. Did I get the birthday hat out with you guys when we did our nets? We saw what this looks like. Okay. Kind of looks like a Pac-Man, right? When you unroll the curvy part of a cone, we know the lateral sides of the pyramids are all triangles. I can't really call that a triangle, although I see it kind of has triangular qualities. It's not a triangle though. In fact, we call it a sector. So in a cone, the curved lateral face, which forms a portion of a circle, is called a sector. You can see what I mean when I say it forms a portion of a circle. If I were to extend this red line all the way around, it would make a full circle. As it is, it's not a full circle. And it's not half a circle either. It's just some portion. It looks like in this case, it looks like 2/3 of a circle. But that's going to be different depending on how big your base on your cone is. So that 2/3 does not mean the same for every cone. So I could stop right here and just say, hey, here's your formula. Pi r squared plus pi r L. You know, L, that's an L. I know it looks like a 1, but my font I'm using for notability makes that L look like a 1. That's an L. I could stop right there and say, all right, you know what you're doing now. There's no point to go on. But I am too inquisitive for that. And I'd really like to know where this formula comes from. So I'm going to have you guys use it. We're going to use it on this cone. And then I'm going to show you where it comes from and how we can relate it to our past formula of B plus 1/2 PL. All right, so how many sides are there on a cone, Lizzie? 2, yeah, 2. It's the smallest number of sides that you can have on a 3-dimensional shape. Just 2 sides. Yeah.
What about a sphere?
Oh, yeah, that kind of gets tricky. You're right. It would just be 1 side. But the way that we use our formula, it makes it seem like there's more than 1 side. And you'll see that tomorrow in the video. But that's a good point. Maybe the sphere qualifies for that. Jace?
For the sphere, it's the inside and the outside.
I don't know what you're saying, but okay.
There are 2 sides, the inside and the outside.
But then we could say that for this too, couldn't we? And we could always double the number. Was right. Okay. It's not. Okay. Pi r squared plus pi r L. Pi r squared, of course, this is going to be our radius of our circle. And so pi r squared is pretty easy. That's the base of your bottom circle there. It doesn't have to be on the bottom. You can flip the cone upside down, make it look like an ice cream cone. It's still going to have the same formula. So it doesn't have to be on the bottom, but it's the circle part. So pi times our radius squared plus pi times our radius, not squared, but times the slant height, which is 8. Now, if I write everything in terms of pi, which I suggest you do because it means you don't have to work with decimals as long, I would just simplify each of these. So Connor Kendall, can you tell me what 4 squared is? Okay, so 16 pi. Alex, can you tell me what 4 times 8 is? 32. Okay, so this is 32 pi. And if I add 16 pi and 32 pi together, that'll get me 48 pi. And I did all that without using a calculator. That's why I like writing in terms of pi. Now, I'm not going to leave my answer like that, but that is helpful. Like now I have to go to my calculator 1 time, and all I have to type in is 48 times 3.14. Jace, what are you going to get for 48 times 3.14?
150.78
Okay,
or 72.
okay. And what would I label it as?
Centimeters squared.
That's right. Now, what's that curvy equal sign mean? Lizzie?
It's about that, it's not exactly.
That's correct. It means it's actually an approximate symbol. It means approximately equal to. And I don't do a good job of using it as much as I should, but anytime I'm using pi and Jace is using 3.14 for pi, we're obviously rounding pi. So anytime I'm rounding a number, that's not exactly what it's equal to, but it's very, very, very close. And so that's what approximate. If you see me use those symbols, that's what it means. Okay, it means I rounded it, which obviously if I'm rounding pi off and not using it as an irrational number, which I can't, then I have to round it somewhere. Yes, Carson?
Is pi like a number?
Correct.
So then how did we like discover pi? If it's a never ending number, we're still discovering it, then how did we even find that out to begin with?
How did we find out? So do you remember what we did on last or 2 weeks ago when we got the string out? We measured the distance around a circle, the distance across the circle. If you do circumference, distance around, divided by diameter, distance across, you get this number that's really close to pi. So what they do, they have supercomputers that do this, is they keep increasing the radius / diameter of a circle, and they keep approximating the circumference divided by the diameter, and they keep getting more and more accurate results for pi. So that's how we're able to discover the next digit, the next digit, the next digit. But yes, it goes on forever. So technically, we'll never, ever be done discovering the last digit of pi.
Well, if they're aliens, this is why they're called their ones that we are.
They gave up on it and said, whatever, we'll use 3.14. Yeah, Xander?
What if we do just discover end of pi?
I won't have a job anymore. Just kidding. I will use 3.14 like I always have. Yeah, I don't really care if they do discover, but they wouldn't. They wouldn't, because I know that irrational numbers like pi never end. Now, pi is not the only decimal that never ends. Any repeating number is also going to go on forever, but there's repetition there, and so we can actually write those as fractions. And so later on this year, we'll talk about rational numbers versus irrational numbers and how to tell the difference. Jace?
I mean, if you did find the ending of pi and you have to use the entirety of pi, then you'd be like writing forever, considering that there's like over a trillion digits. So,
That's correct. Lizzie?
If we don't know how long it is, why do we have a pi button? That's not accurate.
That's true. Your pi button is only as accurate as your calculator has digits. So most calculators have between like 8 to 10 digits. So when you use your pi button, which you're welcome to use, by the way, you can use the pi button. The big idea is homework should accept both. I say should because it's big ideas. It kind of does its own thing sometimes. But on a quiz or test, I'll accept both. So if you want to use your pi button, you're welcome to do that. But you're right. It's now, instead of cutting it off at 2 decimals, it's cutting it off at 8 decimals. It's still rounding. It's still not quite accurate, but it's more accurate. It'll never be perfect. Okay, enough about pi. We got to move on. Where did this formula come from? Well, let's break it down. It's pretty obvious to know where the pi r squared part of the formula came from. The pi r squared part of this formula, and I'm referring to this formula right here, by the way, the pi r squared came from the area of that circle. So we call that the base area, the base circle. So here's pi r squared. That's why I'm going to put that blank right there, pi r squared. This part here is going to be the confusing part. How do I find the area of that? Well, what if I told you that it was a semicircle? That doesn't really look like a good semicircle, but it's close. Wouldn't I do pi r squared and then times it by half? Because it's half a circle, right? Or divide by 2, but isn't that the same thing? Yeah. Well, so a semicircle is a sector of a circle, and so I times by half. Every time I have a sector of a circle, I just need to figure out what portion of the circle is actually here. If this is really 2/3 of a circle, I should times it by 2/3. But it's not always going to be 2/3. How do I know what fraction it's going to be? Well, it depends on how big it is. The circumference of a circle is pi d, or often referred to as 2 pi r, not by me, but people that aren't as smart as me. Just kidding. 2 pi r works for circumference. And so what they did is they discovered, well, the 2 pi r, which is this part of your circle, since the cone wraps around the entire circle, this chunk of it right here that I've got highlighted in red is the same distance. So whatever this number here is, that's how much of a circle I have. But that's the numerator of my fraction. How do I find the denominator of a fraction? Well, if it's 2/3 or 18/40ths, how do I figure that out? Well, the next part, the 2 pi L, the 2 pi L is going to be the circumference of the entire circle, right? Because this is the slant height. The L becomes the new radius of our blue circle. Am I confusing you on that? Sorry if I am. This is the top of your cone. You're looking straight down on it. This part of the cone meets up with this red circle here. This right here, what was the slant height of the cone, is actually the radius of this sector circle. So if I'm going to find the circumference of the sector circle, which is all of it, instead of doing 2 pi r, because this is r, I would do 2 pi L for circumference. And so that's where this comes from. And then I would take that fraction, let's just say it's like half, for example, and I would multiply it to the area of this blue circle, as if the whole circle was there. If the whole circle was there, it has a radius of L, and I would do pi L squared. If the whole circle was there. It's not there. So after I do pi L squared, I'll have to times it by whatever fraction I get for this part. You're like, this is not making it more easy. No, it's not. Okay, but watch what happens. The 2's are going to cancel, and the pi's are going to cancel. Do we agree? Is that part making sense at least? Okay. So now I have this. I've got pi r squared plus r over L times pi L squared. Well, what's L squared mean? Lizzie?
The slant height.
You're thinking way too far into it. L squared means L times L.
I know, but I was trying to think of
What it represents? Yeah, I see what you're saying. So this L right here on the bottom of my fraction is going to cancel out with the L here in the same way that pi canceled with pi. This is on the bottom of the fraction. This is not even on a fraction, so we can see, I guess we could say it's on the top of a fraction over 1. And so those will cancel out. And then I'm left with this. Pi r squared plus pi times r times L, just in a different order. That's where the formula came from. It was discovered, it wasn't created. Yes, Lizzie.
Sounds very.
Oh. Well, don't worry about it. It's not on the test. Now, what I do want to do is I want to show you what formula is going to be on the test, which is that special formula for a cone. I still haven't even given you the special formula for a cone yet. We know circumference is pi d, and that's 2 pi r. Well, here I just have pi r. The 2's gone. So pi r, if the 2's gone, wouldn't that be the same as half the circumference? See what I'm saying? I don't have 2 pi RL, I have just pi RL. So it must just be, if pi r is half the circumference, then I can replace this and just say that this is half the circumference. And isn't pi r squared just the area of the base? Now look what we have. Our special formula, capital B plus 1/2 C L. And what was our old formula? Not the old one. What was the new formula that we had earlier today? Capital B plus 1/2 P L. Again, they're almost identical to each other. So if I'm liking using the special formulas, which you guys, many of you said you are using special formulas, there's not very much of a difference between the formula for a pyramid and the formula for a cone. Instead of perimeter, I call it. I get nothing from you. I have no idea if anyone knows what's going on at all. Instead of perimeter, I call it circumference, okay. And I can use it on that same cone that I just did up here. Watch and learn. Copy, paste. I know that the, whoa. I know the answer is 150.72 because it was 48 pi. So as long as I get 48 pi, I know this formula works. Let's see if it works. Capital B plus 1/2 CL. Okay, well, my base is pi r squared plus 1/2. The circumference of that circle is pi times d. What's the diameter of that circle? Oh, Owen, thanks for volunteering. What's the diameter of that circle? Okay. And Owen, what's the slant height of this of the cone? Okay. Oh, I forgot a pi. It's diameter times pi, not just diameter. So 16 pi, check. That worked. 8 times 8, 64. Oh, but I have to take half of it. What's half of 64? 32. And there's my 32 pi. I'm going to get the same answer because it's going to give me 48 pi. The formula works. In fact, the interesting thing about a cone is that you only have to give me 2 numbers and I can find the whole surface area. As long as I know what the radius is and the slant height, I can find the surface area. So go ahead. I want you to use the special formula to find the surface area. Plug in these numbers to find the surface area. Whoop. Great. Yes. Yep. All right. Bye. If the diameter is 2, what's that make the radius? Jimmy? 1. For the circumference, I want to use the diameter times pi. But because I'm doing half, it's ultimately going to end up as another 1. And the L, the slant height, is 18. So when I simplify, 1 squared is 1. 1 times pi is pi. Half of 2 is 1. 1 times 18 is 18. And what's 1 pi plus 18 pi? 19 pi. And if I actually, oh, hold on a second. Wait a second. Darn it. I wasn't paying any attention. What's wrong? Alex noticed it. No, I did not. Xander, what's different? What do you notice? Why? Did anyone notice that we're measuring in 2 different units? How many? I didn't notice it at first either. How many inches are there in 2 feet? That's 12 in 1 foot. How many in 2 feet? 24 inches. Okay, so we need to go back. This is going to be, the radius is going to be 12 squared. We need to go back here. I don't know why I erased the 1/2. The circumference is going to be 24 pi. What's 12 times 12? Okay. Half of 24 is 12, so I have to do 12 times 18. 216. Is that right? Yep. And then add 144 to that. And that's going to be 360 pi. Definitely a lot bigger than 19 pi. And then if I times that by 3.14, I'll know exactly, well, not exactly, but I'll be able to approximate what my answer is. And it's going to be approximately 1,130.4. And since we converted everything to inches, it would be in inches squared. That's why I knew my answer was going to be wrong, because I was looking up to what the label was. I saw 2 different ones. So we have to double check that. let's save this one and go down to this one real quick. Let's save that one. We can look at that one when we come back on Thursday. Let's look at this last one in our notes. Find the slant height of the cone. They don't want you to find the surface area. They're telling you what the surface area is. They want you to find what the slant height is. So the nice thing about the formula that I gave you, you can use the formula to get that. B plus 1/2 C L. Now, instead of plugging in for L, we're not going to go plug in for L, but we can plug in for everything else. To find my capital B, I have to do pi times radius squared. What's my radius? We're going to be here all day unless somebody shouts it out. 3. Okay. Plus 1/2. My circumference is going to be pi times diameter. What's my diameter? 6. And then I don't know what L is, so I'm just going to leave that. Now, what I can plug in for, I can actually replace S for surface area. I can replace S to 33 pi. So put 33 pi where the S was because it's the same. Let's simplify. This looks like a mess. It's not going to be as bad as you think. What's 3 times 3? Thank you.
Please come to the office for.
What's half of 6?
Scott Branyan, Aaron Branyan, and Isaiah Watson.
Okay.
Please come to the office for an item.
Now, I cannot combine these because this one doesn't have an L. But what I can do is like I do for any two-step equation, I can subtract 9 pi away from both sides to get, what is that, 34, 20, 23, 24. I can't even do math right now. Why am I even teaching? Have I lost you? Is this good? Okay. And then to get L by itself, isn't the 3 and the pi multiplying to the L? Well, solving equations is using inverse operations. What's the opposite of the multiplying? So I'm going to divide by 3 pi. Divide by 3 pi. Of course, the pi's cancel out. What's 24 divided by 3? And we're measuring in inches. My slant height is 8 inches. Isn't that cool? I can use the formula and work backwards to solve for one of the missing dimensions. All right, that's all. You're done. Dismissed. Bye-bye. Hey, your spheres work for tomorrow. Your lesson is going to be on Google Classroom. There's going to be a link for you to click. It's going to take you to Edpuzzle. If you do not watch the video, you will not get the points of Edpuzzle. And it's going to be a huge chunk of the homework points. Make sure you watch the video, then do your spheres homework. Click the video link. You'll see what I'm talking about. I'll see you guys Thursday.